ladies and gentlemen, and everybody else, welcome to our video lesson on 12-6, which is on spheres. Spheres are three-dimensional objects that are in essence just balls. Okay, so spheres are balls. There are a couple words you need to know about spheres. First of all, the radius. The radius of a sphere is a line that goes from center of a circle to any edge. The diameter of the sphere, of course, goes from edge to edge, passing through the circle. The diameter is a special chord. A chord is any segment that goes from edge to edge of a sphere. It's right here in blue. Okay? And lastly, I have the tangent line of a sphere, which is this line right here. It is a line that goes, passes not through the sphere, but just touches the sphere at one point. And lastly, the great circle of the sphere is like the radius of the sphere. I'm sorry, it's like the equator of the sphere. It would be this line right here, past that is the largest circle that I can draw in a sphere. It's like the equator of my sphere. Two formulas you need to know for spheres. The first one is the surface area. The surface area of the sphere, in other words, the peel or the wrapping of my round ball, is going to be S equals 4 pi r squared. And the volume of my sphere is 4/3 pi r cubed. Let's try a problem here for two. The first one, let's find the surface area of this sphere. Well, the surface area is going to equal 4 times pi times radius squared, which then becomes 4 times pi times my radius squared. Well, 9 squared is 81. 4 times 81 is 324 pi, which is equal to approximately 1,117.8. If you look at this problem right here, I have half of the surface area of my sphere. So I have 1/2 times 4 times pi times radius squared. And I also have a circle. The area of that circle, and that's my great circle, so it's going to be plus pi r squared. In this case now, I have 1/2 times 4 times pi. My radius is 7 because the diameter is 14, plus 49, 7 squared, pi. So down here we have 2 times 49, which is 98 pi, plus 49 pi. That is 147 pi, or about 461.8. Just for the fun of it, if I wanted to find the volume of each of these spheres, my volume, of course, is 4/3 times pi times radius cubed. So in this case, I have volume equals 4/3 times pi times 9 to the third power is 729. This now becomes, if you do a little math, 972 pi, which is equal to approximately 3053.5. I look at this second problem, I'm finding the volume of a hemisphere or a half a sphere, so it's 1/2 times 4/3 times pi times radius cubed. And again, so this is 1/2 times 4/3 times pi times 7 cubed is 343. If I multiply these out, cancel the 4 and the 2, okay, I get 2/3 times 343 times pi, which is 686 pi. Whip out your little mini calcs. Whip out your mini calcs. And that equals about 718.4. There we go.